Hello and Assalamualaikum. This is an example of Euler's method in solving ordinary differential equation. We have this question given 5x dy dx equal to 100 plus y. So this is the ODE. Okay, of course later we need to rearrange it. The initial value given, of course we need to have at least an initial value. That's why we call it as solving the initial value problem. So the initial value is here, y at x equal to 0.5 is equal to 20. Implement Euler's method to solve y at x equal to 1.5. So this is the value that we're looking for. Use step size h equal to 0.5.
To solve it using Euler's method, let us start by writing the formula itself. The formula says that the yi plus 1 is equal to yi plus the first derivative, okay, at point xi yi times the step size. So before you can use that the Euler's method, and to calculate the first derivatives or the gradient fxiyi, so let us rearrange this ODE first into the form that we can use it effectively. So let's rearrange so that we can isolate the dy dx on the left hand side of the equation and the rest on the right hand side of the equation. So simple algebra, dy dx is equal to 100 plus y over 5x. Recalling that this is the Euler's method formula, so let's put all the variables into the table so that can be easily calculated and iterated. So we have yi plus 1, yi, fxiyi, and also xi. So this is the table. We fill up the first column as the head I, and then xi, yi, okay, the first derivative fxiyi, and then finally the value that we calculated from the Euler's method. The same as other calculation that involve iteration, it is up to you how to draw the table as long it is easy for you. So in my case, I would like to have all this column. The initial value that was given in the question was the x equal to 0.5. Okay, so x equal to 0.5, and the y value at x equal to 0.5 is 20. So we take it as I equal to 0. What does it mean? It means that we are going to calculate the fx naught and y naught. So referring to that, I is equal to naught, so fx naught equal to y naught. So now we are going to calculate fx naught y naught, which is equal to which is equal to 0.5 and 20. So how to calculate it? You simply substitute these values, x equal to 0.5 and y equal to 20, into the ODE that you have rearranged previously. dy dx is equal to 100 plus y over 5x. So since dy dx is equal to fxiyi, and for the first iteration at I equal to 0, we have this fx naught y naught, so it is equal to x naught is 0.5 just now and y naught is 20. So we simply substitute this 0.5 and 20 into this ODE equation. 100 plus 20 divided by 5 times 0.5, which is equal to 48. So we insert 48 here as the value of fx naught, y naught. Now we can proceed to calculate the yi plus 1 at I equal to 0. So at I equal to 0, yi plus 1 will become y naught plus 1, which is equal to y1. So we go to the Euler's method. y1 is equal to y naught plus fx naught y naught times h, equal to the y naught that we have is 20. So 20 plus fx naught y naught, which is 48. 48 times h, the step size that we have is 0.5. In result, this is 44. So y1 is equal to 44. So now we have the value of y1, which is corresponding to the value of x equal to 1. So this is the corresponding value, I equal to 1. So we have y1 over there, when that we have calculated, y1 equal to 44. 44. The x1 is actually 0.5 times the h, right? 0.5 times h, which is equal to 1.0. Now we can proceed to calculate the fx1 y1. So fx1 y1 is actually equal to f at 1 and 44. So what we do is we substitute x equal to 1 and y equal to 44 into the ODE. So f at 1 and y44 is equal to 100 plus 44 divided by 5 times 1, which is equal to 28.8. Now we write down that value 28.8 into the table. Next, we are going to calculate this yi plus 1. So I now is 1 plus 1 equal to y2. So how to calculate y2? We apply this Euler's method again. y2 based on Euler's method, y2 is equal to y1 plus fx1 y1 times h. So let's substitute the value. y1 is 44 plus fx1 y1 that we just calculated and inserted into the table is 28.8 times 0.5, and the value is 58.4. So the 58.4 goes there, which is can be assigned to this as well. y2 is also equal to 58.4. So y2 correspond to x2, which is equal to, of course, x1 plus h equal to 1 plus 0.5 equal to 1.5. So recalling that the original question is what is the value of y at x equal to 1.5. So this is the answer. At x equal to 1.5, y is equal to 58.4. This is the answer based on the Euler's method.